I recently finished reading Stephen Hawking's last book, Brief Answers to Big Questions, and here's my 10-minute brief take on Stephen Hawking's 10 big questions. This is one of those questions on your literature test which does not have a right answer. I believe that there are two kinds of gods. One which exists in temples, churches, mosques, etc., which gives you rules to live your life, and the other which is the great unknown power. How can humans who are so insignificant on the scale of the universe give the way of God? My belief is that the second God exists. Knowing the mind of this God is knowing the laws of nature. Stephen Hawking believes that humans would have discovered the laws of science by the end of this century, and hence we would know the mind of God by then. Before the Big Bang Theory, people believed that the universe had existed forever. With the help of telescopes, humans have observed the light coming from galaxies. Astoundingly, these observations indicate that galaxies are moving away from each other. The only logical conclusion from this observation is that if these stellar objects are moving away from each other, they must have been closer sometime in the past. From the present rate of expansion, scientists have estimated that the universe must have been very close about 10 to 15 billion years ago. It is estimated that 1 in 5 stars has an Earth-like planet orbiting it at a distance from the star for life to be able to develop. And the comparatively early appearance of life on Earth suggests that there is a good chance of spontaneous generation of life in suitable conditions. So then what are the chances that we will encounter some alien life form as we explore the galaxy? According to Hawking, if the time scale of when life originated on Earth is correct, then there must be many stars whose planets have life on them. Imagine throwing a ball horizontally from your balcony. If you know the speed with which you threw the ball and the height of the ball, you can predict exactly where the ball would land and with what speed. Now, if one knows the precise speed and position of all particles in the universe, then one should be able to calculate their speed and position at some later instance in time, and therefore be able to predict the future. However, according to a proven law, Heisenberg's uncertainty principle states that it is impossible to accurately know both the speed and position of a microscopic particle. The smaller the mass of the particles, the greater the uncertainty. For example, consider a tennis ball of mass 100 grams which moves at the speed of 10 meters per second. If the uncertainty in its momentum is 1%, then the uncertainty in its position is just 10 to the power minus 32 meters, or 5 times smaller than the length of a bacteria. Now consider an electron moving with a speed of 10 power 6 meter per second. If the uncertainty be the same as 1%, then the uncertainty in its position is 10 to the power of minus 8, or twice the thickness of paper. This is a comparatively much higher uncertainty when compared to the uncertainty of a tennis ball. Since objects we interact with are not on the scale of electrons, we do not experience this uncertainty. But on the quantum scale, Heisenberg's principle can never allow us to predict the future with certainty. We can only assign the likelihood of certain futures over others. Einstein did not like this and said that God does not play dice. However, in reality, it seems to be true that God does play dice. To answer this question, let us understand the area theorem. The area theorem states that the surface area of the event horizon has a property that it always increases when matter or radiation falls on it. These properties suggest a stark resemblance between the area of the event horizon and the concept of entropy in thermodynamics. Now, if a black hole has this finite entropy which is directly proportional to the surface area of the event horizon, then it must also have a non-zero temperature.
This implies that the black hole is at equilibrium at a non-zero temperature and it emits radiation. But according to classical concepts, since black holes absorb any and all radiations, how can they emit radiations? Quantum mechanics implies that all of space is filled with particles and antiparticles. In the presence of a black hole, one member of the pair of a particle or antiparticle may enter into the black hole, while the other may escape to infinity. This is nothing but the radiation of the black hole. As particles escape from the black hole, it will eventually lose its mass and disappear.
According to Einstein's general theory of relativity, space-time, a four-dimensional quantity, is warped. Each point in space-time is labeled by four coordinates: position x, position y, position z, and a point in time. The way to travel back in time is by traveling faster than light. However, Einstein also showed that the energy required to accelerate a rocket as it got closer and closer to the speed of light would also increase. Hence, an infinite amount of energy would be required to accelerate past the speed of light. The only way to travel back in time would be to warp space-time so much so as to create a wormhole. These wormholes could connect the different parts of a galaxy, such that if you went through the wormhole and returned back, you might as well have traveled to a point in time before you set out to travel in the first place. As Stephen Hawking states in his book, there are so many areas that Earth is under threat from. One is that the Earth is too small for us. The resources that are required to survive are being diminished every day. In fact, humans have been so kind as to gift Mother Nature with climate change for all her resources. Rising temperatures, reduction of polar ice caps, etc. are solvable problems, but have not been solved yet. Another method of total annihilation is nuclear warfare. Today we have so many nuclear weapons to kill all of us several times over. If we are willing to cooperate and unite to fight these issues that govern us, we will be able to solve these problems. What is the one thing all of us share? Being curious. Since prehistoric times, humans have ventured farther and farther away from their homes. They have done so in search of food and shelter. We are tasked to do the same. Colonizing space is the next step in the evolution of humanity. There is no way forward than going out. Recently, the Perseverance rover landed on Mars, and several moon missions have been planned for the next 3 years. In fact, Elon Musk believes that the first commercial flight to the moon will take place just in 2023. Humans were never meant to die on Earth. They were meant to be an interstellar species. AI is one of the most exciting yet scary things humanity has ever built. Creating algorithms that can be intelligent is one step of evolution that has taken humans so many years. AI today is not that dangerous, although it has already replaced a few jobs. AI of the future, however, will be much smarter, and there will be a time when AI would have outsmarted humans. Imagine building a house for yourself. You'll first start by building the foundation. While digging the foundation, you come across an anthill. You have no enmity towards ants, but it stands in your way of reaching your goal, so you destroy it anyways. Similarly, there may be a time in the future when AI may do things which we humans may just not understand. It may even destroy us. Hence, please make safe AI, everyone.
For everyone to achieve their potential, all they need is a spark of wonder and inquiry. Everyone can shape the future in their own way. We can build our future using what we believe in. We can stand strong together and solve one of humanity's biggest problems and even create bigger ones. We can build the next level of human civilization and even destroy it. we can do anything.
With that, I hope you enjoyed this video, and thanks for watching.